All right, so I want to show you this one with factoring, but when there's only two terms, there's actually what I think is an easier method to do it. So when you're missing a b, like in this case, there's no regular n, I would recommend just solving it like a normal equation. But let's factor for the sake of factor practice. Do they have a common factor? No, they don't. I see two terms that I can square root. What? So remember, this is a difference of squares. Square root of 81n squared is 9n. Square root of 16 is 4. So we'd have 9n plus 4 and 9n minus 4 equals 0. Now you could set up your two equations here, and you could show your work for all of them. Highly recommended. But kind of think of the two steps that you would be doing in your head. What would you do with the plus 4? You would subtract 4. And then what would you do with the 9? You would divide by 9. So we'd have n equals negative 4 ninths. How about on the right one? You would add 4, and then you would divide by 9. So you could show the steps for it, but these are like two-step equations, and you guys are beyond that in Algebra 2. You're so smart. But I wanted to show you the other way you can also do this one. So 81 n squared minus 16 equals 0. So if they gave me this problem and they said, solve it any way you want, I wouldn't do factoring on this one. I only have two terms, so I would just solve it like a normal problem. I would add the 16. So we'd have 81 n squared equals positive 16. I'd get rid of the 81 by dividing it. N squared equals 16 over 81. And then I'd go from n squared to n by square rooting both sides. Now when you square root a fraction, you square root each part. The square root of 16 is 4. The square root of 81 is 9. But also remember, square roots, it can be negative that as well. So also n equals negative 4 ninths, which is the same thing we just got by factoring. Does it matter which way you do it? Nope, you still get the same thing.